to count nodes that are great enough. So the idea is that we are going to count the node. We are going to count the node of a boundary tree, and for this tree, so for example, for this node 6. So for this node 6, so if this is a subtree, yeah, so the subtree gonna be 4, 6, and 3, and we are going to count the node. If the subtree of this node 6, for example, if it has the node 4 and 3, the number of nodes gonna be more than and equal to k, and currently the k is 2, so this is gonna be a count. And similarly for the 7 and for the 5. Yeah, so let me try to explain it. So we are giving this root of a boundary tree and integer k. Yeah, so a node of this tree is called great enough if the following is held. So its subtree has at least k nodes, and its value is greater than the value of at least k nodes in the subtree. Yeah, so first of all, this is easy to understand. So for example, for this node 7, its subtree at least have 2 nodes. So actually at least it's gonna have 6 nodes. So those 6 nodes, like 6, 4, 3, 5, 2, 1, it has 6 nodes, and its value is greater than the value of at least k nodes in its subtree. So its value is 7. So how many nodes? It's gonna be 6. So the number gonna be 6. So 6 is more than or equal to 2. So this means for this node 7, it is true, and similarly for this node 6 and for 5. Yeah, but for this node 4, because there's no children, so it's gonna be it will not be a count. So our count is for this for the root it is 7, for the root of the tree it is 7, for the root of the tree subtree 6 and subtree 5. Yeah, but how can we solve this problem easily? I mean, definitely we need to count how many. So for example, this is the left subtree. So for this 6, 4, and 3, we need to count for this 6 how many nodes that are going to be less than 6. Currently it is 2. But how can we count it easily? So we can sort it actually. So for this node 4, we're gonna return an array. Let me use another color. Maybe it is better. Yeah. So first, let's just analyze the subtree 4, 6, and 3. For this, yeah, let's just analyze the subtree 4, 6, and 3. So for this node 4, we're gonna return an array. It's gonna be this array 4. And similarly for this node 3, we're gonna return an array. It's gonna be an array 3. And for this node 6, we're gonna return an array. It's gonna be 4 and 3. So this 4 and 3, it means the number of nodes, which is less than 6. And similarly for this 5, we're gonna return an array like 2 and 1. So this is the idea. And for this node 7, we're gonna return an array of 1 and 2. Because we are going to have at least 2 nodes. So we just need to check if we can have 2 nodes that is less than or equal to 7. So definitely it is 1, 2, 4, and 3, 6, and 5. But we don't need to return so many of them. We just need to return 2. Because we are giving a k equal to 2. We are just need to check what's going to be the smallest value of those 2 nodes. It's going to be 1 and 2. So we just need to return 1 and 2. And similarly for this node 6, we just need to return a 4 and 3. And for this node 5, we're going to return a 2 and 1. Yeah, so this is going to be the basic idea. So this is going to be a post-order traversal. So while we are checking this node 7, we're going to first check this node 6. And for this node 6, we're going to have a count. If we have a 4 and 3, this 4 and 3 is less than this 6. So we're going to update the result. We're going to count the result. And also for this 5, because we are having like 2 and 1. So the number of nodes is going to be 2. It is less than the value 5. So we're going to update the count. Yeah, and similarly for the 7. So now let's just use this kind of idea to solve the problem. So we're going to prepare a DFS, and inside it's going to be a node. So if not node, this means the node not exist. So we're going to return an empty array. So this is for checking the left child for this node 4 or the right child for this node 4. Basically, we're gonna return an empty array. Now we're gonna record the answer, and for this answer, we're gonna sort it the left and right, and also plus the node value. So it's gonna be the DFS node dot left and plus DFS node dot right. So currently the node dot left and node dot right for this DFS after the final return gonna be an array, and we need to sort them, but we also need to include the node dot value, and we don't need to get so many nodes. Yeah, after sorting, we just need to take the k smallest node. Yeah, so if it is possible, we can get the k smallest node. We're gonna have a tag. So the answers -1 gonna be the biggest node inside the k smallest node. Yeah, this is it. If you understand this one, basically you can solve the problem easily. Yeah. So if the biggest value inside the answers array is still smaller than the node dot value, it means this is okay. We're gonna update the final result. So I'm gonna use a global variable self.result gonna plus equal to 1, and finally I'm gonna return the answer. Now I'm gonna define the global variable, and I'm gonna call the DFS, and finally I'm gonna return the self.result. So this is the basic idea. So for this one, actually for each of the return, so for example, for this node 4, we're gonna have a return that's gonna be an array 4, and for this 3, we're gonna have a return of this array 3. Yeah. So for its left child, it is empty, right child is empty, so the empty plus node dot value, and we're gonna choose the k smallest, 2 smallest, it's gonna be this node 3, it's gonna be the array 3. So similarly for this 6, we're gonna have a return of the array 3 and 4 because the array gonna be sorted, and similarly for this 5, it's gonna be 1 and 2, and for the root node, it's gonna be the 2 smallest, it's gonna be 1 and 2. Yeah. So if this node 7 is still a subtree of another node, maybe 8, maybe there's another subtree. But if from this side we're gonna return a 3 and 4, maybe, yeah. But we still need to return the 2 smallest value, which is gonna be 1 and 2. Yeah, k smallest value. Now let me just run it to check if it works. So the node is not defined, so this is a typo. Let me just run it. Now as you can see, it works. Yeah, so this is an efficient way to solve the problem. As you can see, the speed is okay. It is like 72% and less than 1 second, 0.5 seconds. It is okay. But if we don't use this method, because this method is 10 to the power of 4 times this k, it's going to be 10 to the power of 5 for the time complexity. Basically, it is n times k. And if we don't want to do that, so the answer is going to be very long. So currently, the answer going to be maximum, the length of the answer going to be 10. But if we don't do this, if we don't control it from the k smallest value here, so the answers array can be 10 to the power of 4. So this is going to be an n squared solution. But it still works. Let's just have a check. So here we need to update this answer. It's going to be k minus 1. So this is going to be the biggest value. If this value is smaller than node dot value, it is okay. But we need to check this k minus 1. Yeah. So as we are going to choose the k minus 1, so this means the k minus 1 should less than or equal to length of the answers array, and the answer of the k minus 1 should less than node dot value. Yeah, and basically we need to have a check. Let's just run it. The index go out of the range. Yeah, it should be more than and equal. It is not less than. Yeah, because we are going to choose a value. Definitely less than is not okay. It should be more than and equal. It still goes out of the range. Let me check. I think it's this. We are going to choose this value. Definitely, this k minus 1 should be less than the length of the array. Yeah, it is less than. Yeah, if this index is less than, basically we can choose k minus 1. If it is equal, we cannot choose. Yeah, so this is why we need to have a control of the index. Yes. Now let me run it. As you can see, it also works, but yeah, the time is like 4 seconds. So because this is an O(n)² solution, so that is why we prefer to choose the k smallest value. Yeah, because for the problem sometimes we are giving a value of k, and this is going to be a very small value. Definitely we can solve it. So even we are giving this k equal to 10 to the power of 4, it is still okay. But if this k is big enough, we cannot solve it like that. I think that's the basic idea for this problem. Thank you for watching. See you next time.